Hello and welcome back to the Maths Behind Economics YouTube channel. This is video 14 and we are still working with the exponents, but now we reach the point in our journey that we can concentrate on questions which are most likely to come up in economics. Throughout this video, we will be working with variables and letters that are most common in economics. I again will explain you every time which exponential rule I'm using. Let's get started. Our first example is going to be 2 times p to the negative 2x times p to the 4x. So what can we do here? Well, we recognize that we're multiplying two of the same bases. Each case p is the base, which usually stands for price. And because we multiply them, we can add the powers together. So 2 stays. So in the power of p is now going to be minus 2x plus 4x. Now, I don't know the value of the x, but I know if I have got negative 2 of them and the positive 4 of them together, they make positive 2x. So the final answer will be 2p to the 2x. Next example. 3q to the a over b times q to the 2a over b. So again, similarly to the previous example, we have got the same bases, q, and we multiply them together. So we're going to have to add the powers together. So what's in the power is a over b plus 2a over b. Now we have the fractions that we need to add together in the power. So let me change color and try to do that fraction addition on the side here. So a over b plus 2a over b. Now, I have got a relatively simple job in front of me because the two fractions that I'm adding together have the common denominator of b. So I can just keep that denominator and add the numerators together. So the top numbers are a plus 2a, which together make 3a. So switching the color back, now I can replace the power as 3q to the 3a over b. And if I wanted to, I can leave it as it is. But I also remember, and sometimes it might be useful, that the fractional power can be replaced by a root. So just to show you what else you could potentially do, I could replace this as 3b's root of q to the 3a. Again, remember, whatever is in the numerator, that's gonna stay as the power, and whatever is in the denominator, that's going to become our root. So next question, L to the A, all together raised to the half power, and then L squared. Now, what do we need to do here first? Well, I've got a power that I'm raising to a power, which means that I need to multiply those two powers together first. So L is going to be the a times a half power, and there's another L squared that I'm multiplying the whole thing by. So a times a half, that is just a over 2, because that's how you multiply a whole number and a fraction together. You just multiply the numerator, which in this case is 1, and then you multiply it by L squared. Now, what I've got here, I got here the same bases multiplied together. So all I have to do is to add these powers together. So a over 2 plus 2. Again, switch color and then do that calculation on the side. So a over 2 plus 2. Now, how do we add together a fraction and the whole number? Again, we need to have them to the same denominator. So I'm gonna have to change the whole 2 into halves. So how many halves are there in 1? There are 2 halves in 1. Therefore, I will have 4 halves in 2. So now this is going to be a plus 4 over 2. So the overall power of L is going to be a plus 4 over 2. Again, if I wanted to, I can change it into an expression with the root. So in the fractional power, the denominator is 2, so that's going to be square root. Base is L, so that's not going to change, and the power is now a plus 4. Again, you may or may not want to bring up the root. It really depends on in what kind of circumstance you're trying to manipulate this out. Probably, my guess would be, is that you would leave this form, because that's most common in economics. Next example, k to the minus 2 to the 6th times k cubed to the 4. So what's happening in here? I've got two brackets, so I need to deal with the brackets first. In the first bracket, I'm raising a power to a power, so I need to multiply the exponents, the powers together. Minus 2 times 6 makes minus 12, and then I have to multiply that by the next power of k, which is again, in the bracket here, I'm raising a power to a power, so again, I have to multiply the exponents' powers together. 3 times 4 makes 12. Okay, next step. I have got base k in both terms. I've got k to the negative 12 and I've got k to the 12, so I just need to add these powers together. So it's going to be negative 12 add positive 12. Well, negative 12 add positive 12 just makes 0. And now I remember that any base whatsoever raised to the 0 power is always equal to 1. So this relatively complicated looking double bracket expression is just 1 in hiding. Now let's look at the last example for the video. Y to the 3a over b multiplied by y to the minus b over a. Right, so what can I do here? Well, I've got the same bases, y in both terms, so all I need to do now is add the two exponents, the 3a over b plus the negative b over a together. Again, let us switch color and do some calculations with these fractions on the side. So I have got 3a over b add negative b over a. That is just like taking away b over a. What do I need to do here? Well, I need to bring them to the common denominator. Well, the two denominators are b and a. There are nothing in common in them. So what I need to do, I need to multiply them together to get the common denominator. So the common denominator will be ab. From the first fraction, the 3a over b, from the denominator I'm missing an a multiplier, so I need to multiply the numerator by a as well. So 3a times a, that's going to be 3a squared, because remember, when you multiply the same thing by itself twice, that's the definition of the squared. So what's going on in the second fraction? Well, in the second fraction, what I have is b over a, and the common denominator is a times b. So a is already there in the denominator, but b is missing, so I need to multiply the numerator by b as well. So b times b makes b squared for the same reason as a times a makes a squared. So if I want it to be a little bit more concise, I can write it as 3a squared minus b squared over a times b. Okay, so let's go back to our original question. So y is now to the power of 3a squared minus b squared over a times b. Now, in most cases, you are likely to leave the power of y in this form, but just for the sake of practice, let's rewrite this as a root. So what will be the root? Well, the root is always the denominator in the fraction. So ab is going to be our root. And then y is going to be the power of 3a squared minus b squared. And let's make sure that the root sign goes all the way over the whole of the expression, right? This was our first video on economics team's exponent practice. We have 2 more. I hope to see you in the next video. Bye!